Hello there. This video is to answer the question, how should I factor? And I'm just going to give a quick disclaimer. They are installing flooring in the apartment above me, and it can be quiet for a while, and then there'll be like banging or something that sounds like a sander or a drill. I don't know. If the microphone picks it up and you hear some weird stuff coming in, that's what's going on. But there are several methods for finding the factors of a trinomial. And this video is a side-by-side comparison. Now, I wrote side-by-side in quotation marks because I can't actually fit all 5 methods onto one screen and do any kind of justice with showing how they work. Hopefully, though, you'll find the method that your teacher is using and see how it relates to the other methods that you might use. Always use the method your teacher requires. So if your teacher is requiring you to show your work a particular way, that is the method you want to use. However, if you do have some choice and some flexibility, this video might help you choose which method is best, or even start a conversation with your teacher in your class about different ways that you can show the work for factoring. So the problem that we're going to be factoring is 3x squared plus x minus 4. Now, I picked something that did not have a GCF. If there is a GCF, you would want to factor that out first, and you would do that for all of these methods. So that's not what we're going to look at. Now, the method that I prefer, and I'll talk about this at the end of the video, is something called the area model. And I put that on the same slide with factoring by grouping because it is essentially the exact same strategy. It's just laid out on the page differently. And the area model makes use of the concept of base times height equals the area of a rectangle. But you'll see, I hope you'll see, when we look at them side by side, that you are essentially doing the same thing. So for the area model, make sure I have a color that will show up. There we go. We set up the rectangle, and what we want inside the rectangle is we want all of these terms to be represented inside the rectangle. This is the product, okay? And what we're looking for are the factors, which would be the base and the height. If you've used the area model for multiplication, and when I teach this, I use the area model for multiplication instead of using foiling or distribution, because there's banging upstairs. But so that my students are familiar with the layout of how the area model works. So you would start by putting the x squared term in the upper left and the constant term in the lower right, the 3x squared and the -4. And again, if you've used the area model for multiplication, that is a very intuitive step because you've seen the multiplication come out that way. Now, here's where it gets a little bit not as obvious. You've got to take the A value and the C value, which in this case is 3 and -4, and you're going to multiply those to get -12. Now, what we're going to look for are 2 factors of -12 that add up to our B value. And if you look at the problem there, the B value is a 1. Now, what I tend to do is I ignore the negative for the moment. Okay, I understand that that is a -12 and that my factors are going to need to multiply to a -12, not a +12. But for the purpose of generating the factors, I will just look at the positives. So I can get 12 by 1 times 12, by 2 times 6, and by 3 times 4. And then I come back and say, okay, what do I need these to add up to? Well, I need them to add up to a 1. I can get the 3 and the 4 to add up to a 1 if the 3 is negative and the 4 is positive. Now, just to confirm that I have the right numbers there. -3 times +4 would give me -12. And -3 plus 4 would give me the +1. So that's my confirmation that I have the right numbers there. And I'm just going to use those to fill in the other 2 boxes. Now, just to recap what we've done here. We have taken the product 3x squared plus 1x minus 4, and we have represented that in the rectangle as the area of the rectangle. 3x squared plus 1x minus 4. Now there's an infinite number of ways that you could represent the 1x. You've got to make sure you get the right one, and that's why we use the factors. So you don't just say, well, I could have, negative 2x plus 3x. Like, yes, that would add up to 1, but it wouldn't multiply to the right thing. Now what we do is GCF factoring in one direction, and you really can pick any direction you want. I tend to avoid the negatives, so I'm going to GCF factor right here, okay, going up. I'm going to look for the greatest common factor between 3x squared and 4x, and the greatest common factor between 3x squared and 4x is x, and I just GCF factor going up like that. There it is, greatest common factor. You can go across this way and look for the greatest common factor, and you really can do it anyway, and that takes a little bit of practice, just what's the best way. Now, to get the rest of it, you have the option of GCF factoring along the other rows and columns, or you can use multiplication, and this is where the area piece of this comes in handy. So you can say this is a rectangle here. The area is 3x squared. The base of the rectangle is x. Therefore, what must the height be? Well, the height must be 3x, because x times 3x would give you 3x squared. And now you can do the same thing over here. Here's a rectangle. The area is negative 3x. The height is 3x. Therefore, the base must be negative 1. Or you could just say 3x times what would give me negative 3x. That would be negative 1. And then we can do it here. Here we have an area of 4x. The base is x, therefore the height must be 4. And what I love about this method is that you can use the fourth box as a check. 4 times negative 1 is negative 4. So if you multiply each of these, you should get whatever is inside the rectangle. And here are your two factors. So your two factors would be x minus 1 and 3x plus 4. And there is your factoring using the area model. Factoring by grouping. So for factoring by grouping, I am going to copy this over, okay? And in factoring by grouping, you actually start the exact same way. You take the a value and the c value and you multiply them together. So a times c, you've got 3 times negative 4, which is going to give you the negative 12. And then you go through the exact same process that I did before. And what you're looking for are a pair of factors that will add up to that middle term. And once again, it's the same problem. So we're going to come up with the negative 3 and the positive 4. So I won't belabor that. We're going to see that in several of the problems. Now, what we do when we're factoring by grouping is we do a substitution. So we're going to take out the 1x and we're going to replace that with negative 3x plus 4x, and then we bring down the minus 4. So I'm going to grab the highlighter for a second so you can see what we did. We did a substitution where we replaced 1x with an equivalent for 1x, that is negative 3x plus 4x. And it really is what we did over here. So like I said, these two are essentially the same method, where we needed two things that would add up to 1x so that the area of this rectangle would match the area of the whole thing. Now with factoring by grouping, we are going to consider two groups. We're going to look at two separate groups, and we're going to do the GCF factoring for those two groups. Well, in this first group here, I have a common factor of 3 and a common factor of x. And so I will factor out a 3x. And when I do that, if I have 3x squared and I take out the 3 and I take out one of the x's, I would be left with 1x. And then if I have a 3x and I take it out, I am left with a 1. Over here, I have a common factor of 4. So I'm going to factor 4 out. So 4x, take out the 4, you're left with the x. And 4, take out the 4, you're left with a 1. And what we have here are two common factors. So we have a common factor of x minus 1. I'm going to factor out the x minus 1. So literally doing GCF factoring again. So if you want to see like what am I factoring out, I have this factor of x minus 1 and this factor of x minus 1. So I'm going to pull that factor out. And then what I'm left with is 3x plus 4. So again, now that you see these two methods side by side, like take a close look, it's really the same process where you take that middle term, you split it up, and then you do GCF factoring. The only thing that really I think makes the area model easier is once you do one of your GCF factorings and you have the options. So you have like options, the factoring by grouping, you can juggle the middle terms around a little bit. And then once you get the GCF factoring here, you can use multiplication to figure everything out. Here you have to do GCF factoring twice, and then you kind of do another GCF factoring after that. But notice that we land in the same spot. So those are two very algebraically sound. So in terms of can you explain what's happening, can you justify the process, these are generally favored in terms of the mathematical soundness of the work that you're showing. The next two methods, not as much, okay? And they do work, but they have a bit more of a magic feel to them. And, you know, my colleagues and I have tried to work out like proofs for these to show the rationalization with mixed success. Like, you know, some of the reasoning's a little bit better than others. But here we go. So slide and divide. This is a popular method to use. In slide, what you do is you take the leading coefficient and you slide it down to the end by multiplying. And so we would slide that 3 down, and we do 3 times -4 is -12. Now, I want you to notice that that looks like the same step. Okay, so the other two methods we did, we started by taking the a and the c values and multiplying them together. And so we do that here. We get the c value, a and the c, and multiply them together. Now what we do is we factor this as though there were no leading coefficient. So x squared factors into x times x, and what we're looking for are two factors of -12 that add up to +1. Again, same process that we were doing before is we're going to take that -12 and break it down into the factors, looking for the factors that will add up to +1. And again, it's -3 and +4 because it's the same problem. So we're going to come up with the same factors. And we do -3 and then a +4. And then we get to the divide part. So the slide part was you slide the leading coefficient down and multiply those together. Now we're going to get to the divide part. And in the divide part, we take this number that we have here and we divide it by the number that we slid down. So when I've explained this to my students, I've said, you know, we slid it down by multiplying. Maybe I should put make this like a time sign. There we go. And now we're going to undo that by dividing it, because x squared plus x minus 12 is a totally different problem than the original problem. So we kind of altered it to get the factors, and now we've got to alter it back by doing some multiplication or some division. 3 divided by 3 is 1, and so there's our x minus 1. Now, if it doesn't divide, what we do is we slide it back. So we take that denominator, if it does not divide evenly, and we slide it back to get 3x plus 4. And you'll notice that these are the same factors that we had before. If the fraction can be simplified, so if it was like 6 over, I guess that's a bad number to pick. If it were something like, I don't know, like, I'm just trying to think of something like 6 over 4, you would want to simplify it to 3 over 2 before you did the sliding back. And that usually is indicative of a common factor that you might not have gotten out at the beginning. So there you go. So that's slide and divide. Notice the similarities. But because we're like altering the problem and then going back, it does have this like magical feel to it that if somebody really were to grill you in like, what is this process and why does this work? we can't come up with as great of an answer. Now, the OOPS method, which I have also heard called the European method, I actually have no idea if it's European at all, but this is kind of an interesting method. And you'll notice that it also is going to involve a lot of the same steps. In the OOPS method, what you do is you start out putting the leading coefficient into both parentheses. And that's the OOPS part, because we know that won't work. If we were to multiply those back together, 3x times 3x would give us 9x squared, which we know is not what we want. Then what we do is we go through this same process that we were doing before. We take the 3 and the -4, the a and the c, and we multiply those together to get the -12, and then we find all those factors. So all of these methods are going to take you through that process of multiplying the a and the c to figure out how to break down that 1x, and we won't belabor the point. It's a -3 and a +4. And then what you do in the OOPS method is when you have done this, you will have something that has a common factor in it. And if you look right here, we have 3x minus 3, which shares a common factor. And what we do is we just simply divide out that common factor. And so 3 divided by 3 is 1, 3 divided by 3 is 1. And you might have a common factor in both parentheses. It might just be in one. It is what it is. And so this method, you start by making this mistake that you know at the outset, and then you kind of divide to fix the mistake at the point. So this is these two methods, again, have a little bit, they're a little harder to justify. So if it comes down to, is this an algebraically sound method where you can explain why it works? Much, much harder to do. That doesn't mean there aren't explanations for it. I have no idea how loud that banging is. Hopefully you can't hear it and I just sound like a crazy person. But anyway, these are harder to justify. So I don't typically recommend methods that we can't thoroughly explain and demonstrate that we understand how they work. But if your teacher is using these methods, or you don't need to produce that explanation, you just need to produce the factors, these methods will work. Now, the last method is trial and error, and this is actually how I was taught, and this is how probably a lot of your math teachers were taught to do it. And it is what it sounds like. You just trial things and make mistakes until you figure out what works. So this is a sample of how it might look. So when I was in school, we would set up the parentheses, and then I would think to myself, how can I factor 3x squared? Well, 3 is a prime number, so it only factors into 3 and 1. And then we would always break the x up. So I might do 3x and x. And then you come down here and you look at the 4 and you say, well, how does 4 factor? And I might say, well, 4 factors into 2 times 2. And then I know that this is negative. So when I go to multiply it through, one of these is positive and one of these is negative. And so you just kind of randomly put them in. And then somewhere off to the side, you would do your check. So I'm going to FOIL this through, but you could use whatever method you wanted. And really what you're looking for is the middle, okay? Because the way we came up with those factors was we looked at the 3x squared and we looked at the -4. So we knew those were going to work. We just need to get that middle part to work. And remember, if you think back to the other methods, it was the middle part that we had to do that work for. We had to do the multiplying and then look for the factors. It's getting that middle part to check. Going to be the same issue here. -6x plus 2x is -4x, which is not what I wanted. So we would draw a line through that and we would trial again. And so for the second trial, we might pick 3x and x, and we might go with the 2 and the 2 again, but we might switch that up. Okay, and so then you'd come over here and you go to check it. And one of the things that you'll learn when you're doing it this way is that when you flip the signs, okay, we end up with 6x minus 2x or positive 4x, you learn very quickly that flipping the signs around just changes the sign of the middle term. So what would happen if you did a ton of problems like this is once you got the negative 4x, you wouldn't bother switching the signs around because you would know already that's just going to give me the opposite. And so that's an advantage of doing it this way, is it's going to make you much, much better at guessing. So at this point, we're going to pick the 3x and the x. Now I know that 2 and 2 don't work. So we'll start with like negative 4 and 1. So we'll pick that. And so what would be better is if I copied that right. So we'll do minus 4x plus 1. So we get the 3x squared plus 3x minus 4x minus 4, looking at that middle term. And now I've got negative 1x. Well, I didn't want negative 1x. I wanted positive 1x. So that didn't work. But I have learned from doing a million of these that all I need to do is switch the signs around and I can get it right. And we could go check that one, but we know that that one works. And so that's how trial and error works. And it would work exactly the way that I'm showing it. When I was in Algebra 1, I remember sitting down and doing a bunch of these, and I would have scratch paper off to the side where I would just be running those checks, like just keep running those checks. And what happens is if your teacher gives you like 20 different problems and you've got to trial and error them, you're going to get super fast at doing the multiplying, and you're really going to start to recognize patterns that are going to help you guess the right things faster. So you're going to notice things about positives and negatives and which combinations of numbers work. So if you've got classmates or you got a teacher that is just able to look at a trinomial and see the factors, it's probably because this is how they were taught to do it, and it came from hours of guessing and checking and so forth. All right. So here's a summary. Most methods are variation on the same process, okay? You can see the similarities even with the trial and error. It's that middle piece that you've got to figure out how to put the numbers together to get that middle piece. But certainly the area model and factoring by grouping are the same process. The other ones are similar. Now, I'm a fan of the area model, and the reason I'm a fan of it is because it can be used for other things. It can be used for multiplication, and when you get to it, polynomial division. So it's an incredibly versatile method. If you're using slide and divide or the OOPS method or trial and error, when you get to polynomial division, you've got to start from scratch with a method for conceptualizing it. But if you use the area model, you're going to have a framework in place that will already work and makes the polynomial division honestly very easy to do. Now, the best method is the method that makes the most sense to you and that you can execute proficiently. That's the best method. So don't let somebody tell you that like a method is like some kind of bad method, or you're just, yeah. But you have to do what your teacher is asking you to do. So if your teacher is requiring factoring by grouping, or your teacher is requiring slide and divide, or requiring trial and error, you need to follow what your teacher is telling you to do, and you can maybe use the other methods as a support for that. You might even be able to start a conversation in your math class about these various strategies. Now, for fun, drop a comment below and let me know what method you prefer or what method your teacher requires and why you like that method. And that might help me in my own teaching or to provide videos for my students that will be beneficial to them. So I hope you found this video helpful. Give it a like if you did, and I will see you in a future video.